Hola, what is up, everybody? Welcome back to the channel and welcome back to training day. This is a new series that I'm getting back to. Actually, I started this a while back, showing some, real case scenarios that I do out in the field, apply them to, just kind of showing you why I do things a certain way, so you guys can maybe benefit from this when you're out in the field and you run into some issues. Today, where we're going to talk about dealing with low voltage shorts, troubleshooting, diagnosing the things that you actually see out in the field. I'm going to keep it very basic. And like I said, maybe later on we can get into specific, problems or more technical. But like I said, this is just like if we're on the job, and I'm kind of guiding you through some things, giving you some tips and what you actually will find out. Today's video is also brought to you by Hvacr. Now, they have these HVAC wiring extenders. You guys may have heard of them before. If you haven't, I'm going to show you actually in this video a solution from them that you could actually use out in the field if you have issues with your wiring. And in the next video, I'm going to show you more use case scenarios and how that Hvacr actually does what it says it does. It gives you extra wires without having to run anything else. You can use as little as like 3 or 4 wires to hook up multiple stages. And like I said in today's video, if you have broken wires, shorted wires, any anything that you need to get the customer up and running, there are a few tips and tricks that you can use. But if you don't have enough wiring, enough wires, conductors, you can't do some of those tips and tricks. That all relies on what you have in front of you and what you're working with. So check out the tool link down below as well. I'll try and link as much of this stuff as I can. If you want any more information on Hvacr, I'll leave that link down below at fast-stat.com. And like I said, in the next video, I'll kind of show you how each of them work and what they do. We have, this is particular to an HVAC system, low voltage shorts. So basically you have a transformer and one side is common, the other side is your hot or 24 volts. And that gets fed to some sort of terminal block. It could also feed a control board. There's different things that you're going to see out in the field, especially in today's, state of HVAC and technology. So you have a transformer of some sort. That's always going to be your main or first check, is make sure you have your line voltage going in, 208, 230, whatever it is, and it's going to step it down to 24 volts. And you're going to check the outlet of that and make sure that that is working. There's also some of these that have a resettable fuse. So this one right here, you see that more on commercial. If you guys are doing residential, you're going to see an actual fuse in line either on the control board or somewhere in line on that 24 volts. And if your system is not coming on and you don't have that 24 volts, you need to check either your transformer or that fuse down the line. If this is tripped right here, then you immediately know you have a short, or if that fuse is popped. All it is you got, like I said, a common and 24 volt wire coming out of there. If those two ever cross paths, you're going to get a short. So if you take your 24 volts, cross it over to the common, you're going to get a short. If you cross it, if you get 24 volts that touches any bare metal in the housing of the AC unit, whether it's an RTU, indoor unit, or copper, I've seen that too, where it's laying over the copper pipe outside. That was a common spot that I've seen, because copper is conductive. That is actually what your wiring is made out of, is copper strands or a solid copper piece. If it rubs out on any bare metal or copper, you're going to get a short, and it's going to pop your fuse or the resettable fuse. One thing I almost forgot to mention is your transformer and the way it's tapped. Now I'm on commercial. This is a universal one in particular. It has 120 volt, 208 volt, 240, and 480. It's basically an all-in-one. But if you have a transformer, especially on commercial, where it's 208, 240, and common, and it's installed and left on the 240 or 230, but you actually have a 208 system, you're going to get not the proper voltage on your 24. You might get like 18 volts, something off, where it's going to mess up down the line and you'll have intermittent issues. So always make sure if you're on commercial or you have any of these universal ones that you're tied into the voltage that is feeding it. That way you check, do I have 208, do I have 240, 120, whatever it is, and make sure that it's correct on both sides. So here's the thing, when you walk up to a system, you get a no cool call and you walk up to it. I mean, the first thing I check for is the thermostat, because that's the easiest thing to access. If you're doing residential, maybe you take a walk around the condenser first, but we're gonna go look at the thermostat. If you got a blank thermostat, there's one of two reasons for that. You need to pull this off, open that up, and make sure you don't have any batteries. If it is a battery powered thermostat, you're going to need to make sure that those are replaced. The next thing you're going to look for is, do we have a common hooked up? On this one, it is on the top right. If there is nothing there and there's batteries, more than likely your batteries are dead, you put them in. But you can also try to, I wouldn't say upsell, but recommend that we run a common. Now, you need to look here at the thermostat wire in the wall. And if you're lucky and you have extra wiring, you can just connect one to your common here. And then on the other end of that would be in the indoor coil, indoor furnace, or on an RTU, it would just be wherever your transformer is, this terminal board right here. And then just ground it out or run it to a common. Usually there's a common on a terminal board, a board, control board that you can hook it up to. Maybe nobody hooked it up. That way, if the battery ever fails on it, you know, it can still run. That won't be a nuisance call. Now, again, if you can't, let's say you don't have any extra wire, you're stuck with just whatever is being used. Technically, you could steal a wire, but then you're going to lose your heating or whatever, second stage, whatever it is. Or you could get a fast stat common maker. So they do make one of these that only gives you one extra wire to use for common. And in that instance, you would hook it up here to your common, throw it in and wire it up to the diagram. We'll get into that and leave it. There's a little dongle that stays in the wall there. It doesn't generate a lot of heat or anything like that. And maybe they have, or they want to upgrade to a Nest thermostat. That would be the great, you know, scenario for that, is using fast stats common maker. You know, get a solution when you don't have enough wiring. So you want to make sure your thermostat is working properly first. So you take that off, check for batteries, check for a common. Typically for like any Wi-Fi thermostats, things like that, they're going to require a common, not batteries. So then you're going to need to find out why we don't have a display, right? So you lost your 24 volts. Next steps vary in different situations. Obviously, if everything is working properly, you're going to start checking, you know, your capacitors, if there's any low pressure switches, charge, things like that. There's going to be different things that you need to look at, right? But if you go in there and it's a low voltage issue, it's going to be one of probably two things. You got a short to ground, which either popped your fuse or your transformer, or you're going to have a broken wire. In that instance, everything else is working, but you're not getting cooling or heating, or you're not getting that 24 volts for that thermostat. So you're going to need to go through, and basically what I do first is make sure that we're calling. So wherever this lands on a terminal board or control board, whatever it is, that's where I typically go to check voltage. So all you're going to do is grab a meter. The field piece ones are pretty good. You can get a basic one, or go to Home Depot, get a Klein, or Milwaukee. They do HVAC meters now, so you guys can go pick one up. But basically, you're going to check your R to common, and you're going to make sure that you have 24 volts. That's your first step. If you don't, obviously, you need to go look at your fuse and transformer. Now, if that fuse is popped, there are a few tools that you can use, such as a popper. It's typically available in like a 3 amp or 5 amp, and it's resettable. So typically you hook that up in between where the fuse was supposed to go, and you reset it, turn the system on. I would start with setting this thermostat to fan only. make sure your blower comes on. If it pops immediately, you know that from green to the blower motor, there is a short somewhere. If the fan does turn on, the next thing you want to do is set it to cool. And if it trips, then you know you got a short going to your cooling, either from Y to the board, around there, check any safeties that it has, or it's going outside and you got a short going out to your contactor. Because all that does is send output to either the board or just straight out to the contactor. It's going to land on the contactor coils right here, which is low voltage. On these contactors, you got high voltage on 2 poles, 3 poles, whatever it is that you're working on. And these little side connections on here are the coil, which is 24 volts. All it is making sure that that stays either open or closed. Magnetic field, when it energizes, will close those contacts. So the easiest thing you can go is, if you do have a short, let's say you did pop a fuse or transformer, is you're gonna go over to continuity. You can also check resistance. We'll talk about that in a minute. But always test your leads. Make sure you get that tone. Another thing that I do is check whatever ground I'm using. So if this was a panel and I'm going to use that as my ground to check to each terminal, I'm going to check that first. I don't think I have a metal panel here, but I'll use common as an example, where I'm going to check to common. I'm going to put my lead on that panel or screw also and make sure that I get a tone first. And then I'm going to start checking each one. Now, when they're connected, you might get a tone if any of the wires land on the contactors, because there is, that's a coil. You're going to get continuity on that. So when you do check continuity, I know people prefer resistance, prefer this or that. Make sure you unplug any wire. So if you want to isolate this thermostat, you isolate it here and you isolate it off the board. You remove all those wires from the control board or the control, and then you start checking continuity to ground. You know, this thermostat wire itself is what I'm concerned about, that it's grounded. And that could be, like I said, either this rubbed out on metal or this deteriorated and you have an issue internally on the wire between the unit and through the building back out. When you isolate your wires, that's what you want to check. So then you're checking, like, do I have continuity to each wire? Because I shouldn't. Each wire is its own path. And then from there, check each end to ground. So typically when I'm checking, and I feel like I have an issue with the wiring, or I want to eliminate that thought, I will remove the faceplate. And by removing that, technically all of these have their own terminal and they're not going to be touching, because this is what makes them touch or close contact with. So I'll remove that at the thermostat, the faceplate, make sure that that's not calling or anything like that. And then I'll also take off the wiring from either the control board or the terminal block. So then remove your R, common, green, all that stuff, and make sure you have the power off at this point if you're checking for something grounded. So then you're going to go to each one and you're going to start the wire itself. You're going to start checking to any good metal. Like I said, make sure that it is a ground by checking it. And then check each one to that metal and make sure it's not touching. It can be continuity. If you guys are checking resistance, you want OL or some higher form of resistance. A contactor, I've done this one before. If you're checking a wire that is still hooked up to the contactor, it's going to give you a reading. If we go to resistance, that one is going to give me 12 ohms of resistance. So you can have 12, 15, there's different numbers for contactors. So you need to have something of resistance. If you have like 0, 0, 1, 0.01, 0.02, there's no resistance. That means it's shorted. So if you guys are checking by resistance, you need to have some sort of resistance or overload, OL, and that way it's telling you that there's nothing touching. If there is little to no resistance, that is a short, which brings me to my next one. If you figure out that it is shorting out on a blower motor or cooling or heating, you can also go to that contactor. Like if it's a residential, you can go outside. If it only shorts out, blows a fuse on cooling, you can go outside and check that contactor. If you guys are working on RTUs, typically they're going to have a few in line. Sometimes a blower has its own contactor. Sometimes it's in line with another one. Sometimes it goes through a relay. But you can start with the contactors themselves. So if you suspect that it's only tripping when the compressor calls or cooling calls, then you're going to go and disconnect your wires off the coil for that contactor, and you're going to start checking each one. Like I said, if you get anywhere, I've seen them as low as 7 or 8 ohms, but you need to get anywhere in that 10, 12, 13 range. I've seen some that go 16. Somebody mentioned that there's a formula, but basically the higher it is, whether like voltage, like if you guys are checking a 24 volt coil, it's going to be typically, I think, 10 to 12. If you're checking, a higher, because I deal with commercial equipment, sometimes that coil is 120 volts to that coil. Sometimes we have 3-pole, 208, 230. All that varies with that resistance on that coil. So typically I've seen a few different ones. As long as it's not 0 or 0 point something, I know we're good. So if I go to a contactor coil, it's happened plenty of times where, once one of these is calling, like the outdoor unit or your cooling contactor, whatever it is, you go in there and you're like, okay, I have no resistance. Let's change out that contactor. I mean, those give out over time. There's a lot of wear on contactors. I know it's been brought up in my comments. These typically need to be changed out if there is so bad of pitting going on inside between the contacts, because you can take off that faceplate and check that. That has more to do with the high voltage. Today we're talking about low voltage, but typically contactors are one of the weak points of an AC system. I'm not saying they should be changed out every 6 months or anything like that, but there's something that you need to keep an eye on. The resistance, if it goes down too low, it's going to start causing some shorts, and those contacts can also cause you some issues. So just repeat this process for anything that you suspect in the system. If you have safeties, board issues, which I'll get to right now. Basically, like I said, isolate the thermostat by taking off the faceplate. Isolate the other end by removing it off the board or terminal connections, or whatever you guys are, wherever it ends to, right? And make sure you check it that way. Now, if your wiring is okay and you're still not either getting a call, like it is cooling, but it never, the contactor never pulls in, obviously wait for that 5-minute delay or whatever delay that the manufacturer specifies. But there's a few other things you can do. Now, if it's a battery powered, it's a lot easier, because once you pull it off, it still is calling. And these are the little terminal connections on the back that make contact with the plate, the wall plate. What I've done too is I do run into a lot that are battery powered. So if you happen to pull it off and it's still calling on this, you can start checking with continuity and making sure these contacts are closed. I've had thermostats that do not close their switches, and I go from R to Y1 for cooling, and it never closes. It never gives me that tone. So then I know this thermostat's bad and I'll change it out. If you're not sure that it's your thermostat and it doesn't take batteries, you need to check it with the faceplate off. You would make some jumpers. I have this one with a Wago clip. You can also use a wire nut, because I cut up several jumpers. That way I can call different stages of cooling and different things. So if I need to isolate and call for, I would hook it up to R, and then I can hook it up to either green, yellow, Y1, Y2, whatever it is. So I can start making sure that it's not the thermostat. So if nothing ever pulls in and you're unsure, use a jumper. And if it still doesn't call, then obviously you might want to look for a broken wire or something that is tripped. on RTUs, I think residential, you're going to start seeing it more often is safeties. If you guys have a low pressure, high pressure safety switch, peanut style or whatever it is, they're usually in line with your contactor. So if you're still not getting 24 volts here at the coil, then you need to start also checking those pressure switches. All you're going to do is check across. If there is no voltage, you're good. If there's a tone, if you want to check it that way, you're good. Or no resistance, you're good. If you check across and you do get a voltage reading of 24 volts, because that's what's going through there, and then it's open because you're grounding out the other side and you have a hot side on the other. And like I said, if you don't have a tone or you have resistance OL, you need to make sure that that safety is not tripped due to low charge, high discharge temperature. You're gonna have to make sure that when you check your pressures, that is not an issue. All right, so what can you do if you find a shorted or broken wire? Obviously, best thing for you to do is to rip out the wire and give them a whole new line of thermostat wire, and preferably one that has extra conductors for future issues. Now, if you do have extra conductors, let's say you have this kind of setup where it's a basic 5 or 6 wire setup and you see some extra wires, you can actually steal some wires. I've even done so where I'm in Texas and we don't really use heating. I might disconnect that and borrow that wire to run my cooling or second stage. So typically, let's say this white W1 white wire is no good. It's either shorted or broken. You would remove that one completely, cut it off, take it off this terminal right here. And if you see any extra wires, it could be like this orange or black, connect that there and do the same thing on that indoor unit or wherever that thermostat wire lands. Now, that's best case scenario. Like if you find that, you're lucky. You know, somebody actually gave you some extra wiring there and some slack, hopefully, and all that. So, you know, that's one way to do that. You can just take another wire and condemn the one that doesn't work. You can also do that, like I said, for broken wires or shorted wires. Now, in an emergency, like I said, I'll take away the heating because we hardly ever use that here, and do the same process with that and land that over on cooling, whatever it is. But I mean, you can also use fast set. This one here gives you one extra wire to be able to use as a cooling, heating, whatever extra control wire you would need on this thermostat. When you're looking for a short, obviously you isolate it, you get that short to ground with the meter, and you figured it out that way. How do you find a broken wire? If you suspect a broken wire, let's say you think everything's good, your thermostat's good, and you're still not getting that calling out to the control board or the contactor, wherever it lands, you can also isolate the wires again. You want to actually remove them off of this wall plate. Make sure they don't fall into the wall. Make sure you kind of pull them out. And also isolate them where they land. You would only need to isolate 2 for this kind of troubleshooting. You would take the broken one that you suspect and the next wire or one that you know is working, and then twist them together. That way it's looped to the outside or wherever else you're doing your troubleshooting. And then you can go in there and kind of check for continuity. And if I put the blue and the white here together and I'm outside checking those 2 wires, if I check each end with continuity, then I know that it's not broken. But if I don't get continuity, then that line at some point broke, and it could be in the building, somewhere along the line. So I've seen it with exposed thermostat wiring. It gets brittle. Either the jacket and sleeves start to deteriorate and we get shorts like that, or the wires themselves just get brittle and break. But you guys might deal with like new construction where somebody cuts that line, that thermostat wires, or the remodel renovation scenario, they run a staple or nail through the thermostat wiring and cause a short or break that way. So just be mindful. Hopefully this was helpful in some way. I hope those clips, I was trying to use like real world scenario type of situations to kind of visualize, help you visualize, and maybe help you when you're out in the field. If you guys are enjoying this series, please drop a like. Make sure you subscribe so we can do some more of these in the future. And again, thank you to Fast for sponsoring this particular series on low voltage troubleshooting and how thermostats work. If you guys are interested, they do offer so many different models, whether you need one extra wire, several extra wires. You just need that common to make that Nest or Wi-Fi thermostat work. And it's impossible to run all new wiring. You know how much of a hassle it can be. And you probably have heard me complain that I work in restaurants. So to have to run the wiring through a drop ceiling that goes over where they cook to where the people eat, and they're not going to want me dropping insulation or whatever else you find in those attics, dust and different things falling on them or in their food. Again, another tool in your arsenal. It's just something that you can keep on the van. And I know some guys that use it a lot, some guys that use it only in emergencies. I have it if I need it on my van at all times. So thank you again. And if you guys are interested in how they work, make sure you check out the next video in this series. And I'll leave this all in a playlist on my homepage, easy to access. Like I said, I hope this helps somebody somewhere. And again, if you have any suggestions or requests, leave them in the comments. If you guys have anything that I missed or any advice on this particular topic, also leave them in the comments to help somebody that finds this video. I appreciate you guys. Remember to like, comment, subscribe, all that good stuff. See you guys.